Okay, so today we're just back to polynomials. We're not going to do a ton today. So there'll be, I think you get about half the period to finish this assignment up. If you haven't finished the test, you should be able to take care of that. Polynomials. So as we said last week, a polynomial is all it is just a sum of a bunch of monomials. That's it. You're adding up a bunch of separate terms. Each of those is a monomial. Let's review what are our rules for a polynomial, right? Each monomial that builds up the polynomial has a coefficient and then a power of a variable, right? Okay, so what are the rules? Perry, what can you tell me about the coefficients? What has to be true of all the coefficients? Say it again. They have to be the same, but they have to, what kind of a number do they have to be? The numbers that are being multiplied by the variables. What's our only restriction? They don't have to be positive. They have to be real. That's it. They have to be real. So they can't be imaginary. No i's, right? How about the exponents? Peyton, what do you think about tell me about that. What must be true of all the powers of, like, let's just say they're x's. Well, all the exponents have to be what kind of number? Well, okay, but I mean, they, like the exponents, could they be fractions? They have to be whole numbers, don't they? Yeah, they can't be fractions, they can't be decimals, they can't be negative. Okay, so they have to be whole numbers. All right, so some things, the ways that we categorize and talk about polynomials. We use polynomials a lot. We need to be able to describe polynomials in a way that makes sense to us, right? So the highest exponent of a polynomial determines the degree of the polynomial. Okay, and that's how we assign a degree to a polynomial. The standard form for a polynomial, all it does is it's going to write each of the terms in decreasing order of their power of the variable. So we start with the biggest power of x, that monomial comes first, and then the next monomial would be the one with the next biggest power of x, all the way on down the line. Okay, so let's just practice putting a couple of these into standard form. In fact, let's just do, well, yeah, we'll do those two. Okay, so what about number 10? Everybody stare at that for a second. Which term would need to go first there, do you think? Andre, what do you think? Okay, you sure? Is there any other bigger power of k there? There you go. So negative k to the fifth. That's how we'd say that, right? Negative k to the fifth. Kyler, what comes next? Minus 3k cubed, right? That's what you meant? And then what's next, everybody? There you go. 1/4 k squared. And then what, 8k? And what comes last? Yeah, the constant, right? Because that's really, the constant is k to the 0 power, if we remember that power, the 0 power of exponents, right? Oops, minus 1. Okay, so there it is. There's our polynomial in standard form. Now, number 12 is that's kind of a challenge one. I don't think I'm going to give you any on the assignment like that, but I just want you to be familiar with that. You'll see that potentially next year. Won't see a lot of that this year, but next year you'll see more stuff like this. So can you tell me what's the term with the most powerful exponents? Or is it a tie? Okay, but there's another one that's tied with it. Y to the fourth, exactly, because look at this. That's really a y to the 1, right? So if I add up the exponents, all of the exponent of the variables in this term, they add up to 4, right? Same thing with this one. So those two are kind of a tie, right? Which one goes first? Well, the way we do this by convention in math, we'd say, okay, we always like to organize things alphabetically when we have many variables. And so we'd always start off with, if there's a tie, the term that has the biggest power of the first alphabetical exponent would come first. Well, x comes before y, so that term would come first, and that one would then come second. See how that works? Is it a big deal? Not really. But I mean, that's how we would do it. So we would get 9x cubed y minus y to the fourth. Which one would come next? 5xy. Yeah, good. So that would be the third, wouldn't it? What's next? Negative x squared. Yeah, there we go. That's 4. And then finally, plus 2. Okay, give me 1 to 5. Does that all make sense? How we organize those things? Okay. Okay. Question?
So for those ones, I probably just missed somewhere, but why are we like combining the k's and the x's?
Okay, well, can you? Are any of those like terms?
Oh, never mind. Yeah.
Right, you would. If you could, you would, but none of those are ever like terms in any of these in this case, right? Yeah. Okay. Okay, so now we're just going to play a little game of thumbs up, thumbs down. So look at the first one there. I want you to tell me, is it yes, thumbs up, it's a polynomial, or no, thumbs down, it's not a polynomial? Just take a stare at that and everybody vote with your thumbs. What you're looking for, is there anything that looks kind of fishy there? Something that looks a little bit unpolynomial-like going on? What do you think? Hold on. Okay, so that's a fifth root of 7. That one actually is okay. It looks goofy, but that one's okay because that's just a real number. All that is like the square root of 7, cube root of 7. That's just the fifth root of 7. It's going to be some infinite decimal that never repeats, never terminates. It's irrational. That one's okay. But which term up there is not okay? There's one term that doesn't work. Yeah, square root of x. We can't have variables inside square roots. That does not look like a polynomial, right? Polynomials consist of real number coefficients, and that is a real number coefficient. That's fine, right? The numbers that are out in front of the variables or the constant just have to be real numbers. But then all of the variable pieces, they all have to be what we call power functions. They're just going to be a variable to a whole number exponent. You can't have variables show up in any other way or it makes it not a polynomial. So because of that term right there, this is a big fat no. That's not a polynomial. Okay, what about the next one? Is it a polynomial? Now, these may not all be in simplified form, but if I simplified it, would this be a polynomial? Yeah, everybody agree? That one works, doesn't it? Look, I could just divide each of those terms by 5, and then I could rearrange them to write it in standard form. Let's do that. If I wrote that in standard form, what would the first term be?
Or negative 3x cubed.
Yeah, everybody agree? Because look, if you do negative 15 divided by 5 is just negative 3. And then we want to do the x cubed term first. There's the first one. Lily, what's the second term going to be? There you go, plus 4x. Okay, good, because 20 over 5 is just 4. And then last one, Treasure, what's that going to be? 2, that's it. 10 over 5 is 2, good. So that one is a polynomial, right? Okay, next one. Everybody look at that, and everybody's got to vote. You don't have to be correct, but you got to vote. You got to give me a little feedback here. I want to know where we are on this. Is it a polynomial? Okay, you're right, Kiana. How come? Which term looks goofy? That one right there? Yeah, look, that's not right. You can't have an x on the bottom. That doesn't make any sense. It's got to be an x on the top of a fraction, if there's a fraction, to a power. So that one's a weirdo term. That one makes it not a polynomial. And then the bottom one, pretty obviously, what's that going to be? Thumbs down. Well, I mean, look, cosine x, right? That doesn't look like a polynomial, right? That's a trig function. So that's not going to work. Okay? All right, so next step is how do we got to get a little better at describing these things. So we always classify polynomials in two ways. There's two parts to the name of a polynomial. We classify by degree and we classify by the number of terms. So these are the specific words we give to polynomials based on the degree of the polynomial. And what's the degree again? How do we determine the degree?
Coefficient.
Not the coefficient.
How many terms?
Okay, the biggest exponent, the biggest power of the variable in the polynomial, that determines the degree of the polynomial, right? And we'll see, in a few days, we'll see how important that is. Like that dominates the behavior. The first term, we call it the leading term in a polynomial. We'll see pretty quickly that dominates the behavior when the values of x get big. Anyway, I don't want to jump the gun. We'll get there soon. So if the polynomial has degree 0, we just call it a constant polynomial. That's kind of a weird one. We don't even oftentimes have to really think about those as being polynomials, but they are. If the degree is 1, we call that linear. If the degree of the polynomial is 2, we call that quadratic, right? So we've already done a whole unit on quadratic polynomials, but we just didn't even know they were polynomials at the time. Degree is 3, we call it cubic. Degree is 4, we call it quartic, like there are 4 quarts in a gallon. That's an easy one to remember. And then degree 5 is quintic. Okay, we don't say quintic that much really, but it's a word that it's going to be on the assignment, so you got to know that one. The number of terms, based on the number of terms. If there's only one term, we call it a monomial, right? As we learned last week. If there's mono means one. If there's 2 terms, we call it a binomial. 3 terms is a trinomial, and we saw that last unit. And then anything bigger than 3, 4 or greater, we don't bother giving it a specific name. We just call it a polynomial. Okay, so let's name each of these. How about that first one? What's that first one going to be, Persephone? What's the degree going to? It's linear, isn't it? Good. Because it's degree 1. So there's the first part of the name is linear. What about the number of terms? What do you think? Number of terms on that one. Let's see here. Who have Kenny? Binomial. Yep, 2 terms, so it's a binomial. Okay, it's a linear binomial. Okay, how about the next one? Degree. Veronica, what about the degree? What's the biggest power of x? 5. So then if so the degree is 5, so what's that make it then? Quintic. Yeah, there you go. So it's going to be quintic, and then we need the number of terms on that one. Marie, what's the number of terms? So what would that make it? Yeah, it's a quintic trinomial. Okay. What about number 15? What's number 15 going to be, Kyler? Constant monomial. There you go. It's a constant monomial. Okay, give me thumbs on that one. Everybody, that makes sense? Constant monomial. Okay. Let's see, Peyton, how about number 16? What's that going to be?
Cubic.
Okay, cubic what? Polynomial. Yep. Cubic polynomial. Number 17. Lily, what do you think about that one?
Quadratic trinomial.
There you go. Quadratic trinomial. Degree 3, or 2, sorry. 3 terms. Okay, number 18. Persephone. Say it again. Quadratic. Sorry. Quartic. Sorry. Quartic what? Monomial. That's it. Got it. Good. Quartic monomial. Okay. Now this is kind of a weird one, right? This is sort of a challenge problem. Okay, what do you think? What's the degree? Treasure, what do you think the degree of that one's going to be? This one that doesn't have a number by it. 3, is there a, but they may be out of order, right? So if it is out of order. So is there a term that has where the exponents add up to more than 3? Anybody see one? Because look, this term right here, that's 3, and that's a 1, isn't it? So that's giving me 3 plus 1 is 4, and that one's a 4, right? So the biggest term, the degree of this thing has to be 4, because the biggest combined power of the exponents in any term is 4. That's kind of a weird one. So we know that it's quartic. How about the number of terms? What's that gonna be here? Yeah, polynomial, right? There's more than 3, so it's a polynomial. Okay, I want just an example of just a cubic binomial. Just any example.
6x cubed plus 5x.
Good. That works. Okay. Oh, and give me another one. Cubic binomial. Say it again.
A cubic one?
Yeah.
All right. 7x squared. Or sorry, 7x3.
7x cubed.
Yeah,
Plus 2. That's a 3, by the way. There we go. Okay, good. How about a linear monomial? Perry, give me an example of a linear monomial. 6x? Yeah, that works. Okay, makes sense? Okay, all right. Okay, that's it for today. I told you, today's a short one. So the assignment is up and ready to go. Anybody need to finish a test up? Okay, or start a new